Hey, welcome back. We're going to jump to 9-6. All you people that are really busy on Monday, we're going to get you ahead. Okay, so on Monday, this is going to be the goal for Monday is to complete this assignment. By Tuesday, people should have this assignment done. So if you want to get ahead of yourself, this is what we need to do. We're jumping to 9-6 because I think it makes more sense. You just spent 2 sections talking about simplifying rational expressions. Now we're going to solve rational expressions. This is different. It's fundamentally different in the fact that instead of getting a denominator, we're going to decide what the denominator would have been and multiply through to get rid of it. If you think back, we used to do this. I used to tell you in the beginning of the year, I said, you know, if you ever have an equation, if we have an equation that you want to get rid of a denominator, we can blow this thing up. We can make it 4 times bigger. So we would multiply through, giving every term a 4. Multiplying through by 4 gave us the situation that we could cancel the 4's here and finish multiplying. So I just get rid of the fraction. You got to be careful of this, and I have people that trip on this baby. The 4 cancels with the 4, leaving a 3x in the first term. 4 times 1 is a minus 4, equaling a 32. You can add 4 to both sides, so we get 3x equaling a 36. Divide by 3, and you get x equaling 12. 12 would be my solution for this problem. So I had 3 terms with a denominator of a 4. Instead of getting denominators everywhere, I multiplied through by what would cancel out the denominator. I made the whole problem 4 times bigger. By doing that, I was able to finish and solve the problem. Now, what we're going to have are problems that have not just the 4 downstairs, but we're going to have something more with an expression in the denominator of a term. And you may have multiple, but I just thought I'd ramp it up a little bit at a time here. We have 3 terms. These 3 terms make an equation. To solve this, I have to multiply through by what would have been the common denominator, which in this case, because the only denominator I have is x plus 3, that would be my denominator. So I need to multiply through. Instead of trying to get a denominator, I'm going to multiply through by x plus 3. And using parentheses is imperative. Multiplying through by x plus 3. The cool thing about doing that is we're so lucky that this x plus 3 reduces, and I get x minus. I end up with, because this doesn't reduce here, 6 times the x plus 3 and 8 times the x plus 3. Then we continue solving this. Now you got to watch out for tricks like this too. You see this minus sign? It'll come back and bite you. We need to make it a plus, a negative, and distribute the negative 6 in. You end up with x plus a negative 6x, and then a negative 6 times 3 is plus a negative 18, equaling 8x plus, careful, 24. If we put all like terms together, this becomes a negative 5x minus 18, equaling 8x plus 24. We can subtract a 24 to this side. I can add 5x to this side. I don't know how great this is going to work out, people. I end up with what? What is this? I got a 13x equaling something nasty. What? I love doing this without your help. 42, negative 42. Divide by 13. I'm totally okay with this ugly answer. X is a negative 42 thirteenths. By the way, there was a restricted value to this whole thing. As I solved this whole problem, what I had to make sure of is that I didn't actually lose a value. What is the extra value that we could never have? What's the restriction? Well, back here I had x plus 3. So by the time I get done solving, the restriction is that x cannot equal a negative 3. Well, I'm lucky. The reason I need that is because if this answer would have been a negative 3, I'd have to throw it out. So you want to think about restrictions. When you get your final answer, you double check. Because if this would have been a negative 3, I'd have to cross it out. It's not. It's something nasty. We're all good. Okay? It's a little bit more than negative 3. So it's a quality answer. And that's it. So we multiplied through to get rid of the denominator. Make sure you distribute. Watch out for the dirty pig. You got to go plus and negative and distribute the -6. Watch the 8. Distribute that. There you go. Okay, so let's ramp it up a little. Since you're so smart, and you are, I'm very impressed, by the way. You guys are doing great. Here's the next problem. Look at this. We got a denominator of x plus 1, x minus 1, and x squared minus 1. Oh man, isn't this a mess? Well, it's really not that bad because this factors, and you've got to look every time. You've got to hope that this baby will factor for you. And it might be a trinomial sometimes. You can guarantee that chances are, if this is something big, it's going to factor into something like these. Okay, this is a difference of squares, so we can take this example and just simply factor the denominator right here. This is an x plus 1, x minus 1. How convenient. Right now I have an x plus 1 for a denominator in the first term. Here I have an x minus 1. Here I have both. What would be the common denominator? This whole thing. I don't really want a common denominator. What I want to do is multiply through by x plus 1, x minus 1. Notice I'm not writing it on top and bottom now because I'm solving. I'm multiplying through to get rid of the denominator. The biggest mistake people make is that they don't take the time to write this. Okay? If you take the time to write this, you will get it right. And if you don't, you'll get it wrong, and I guarantee it. And I'm sorry. But you really need to write what it is you're multiplying through by. Then you get to do the fun part. This is cool. You actually get to cancel. The whole point of multiplying through by this, what would have been the common denominator, this least common multiple when you multiply through, the whole point of doing it is to be able to cancel. We want to be able to take the x plus 1 with the x plus 1. I want to be able to cancel x minus 1 with the x minus 1. Both of these factors cancel with both of those, leaving what? I end up with, when I do this, I guess I had it ready to go again, x plus 1 drops, x minus 1 drops, both of these drop. The equation we're left with is 2 times x minus 1 minus 1 times the x plus 1, equaling all that's left over here is a -2. That was the purpose. The purpose was to get rid of all the ugly denominators. Now it's just a matter of algebraically simplifying this and cleaning it up. And I don't know if you really need me to go through doing that. I'll do it really quickly, but if you want to cut out, I'm okay with that. And I'll post your assignment. But for those of you that want to see, here it goes. Bam, bam. You got to distribute that -1. We got a 2x minus 2 plus a -1x minus 1 equals a -2. 2x with a -1x is a 1x minus 3 equals a -2. You add your 3 over. You got a 1x equaling a 1. X is a 1. There it is, people. You knew that already. I know you did. But there it is. Closure for everybody that loves it. And I'll post your assignment. So you're solving. Take advantage of looking at Hot Math. It's got the odds. Make sure you're looking at the examples in the book. If you really need the help, watch this again. Or listen to the online avatar on Glencoe. Good job, you guys. Good luck with your test on Friday. Or Monday. Or Tuesday. Do your math. Love ya.